Hey, everyone. So first of all, thank you, Dave, for inviting. I'm glad to be here. I'll be here in San Francisco for 4 months approximately, so it's good to meet people and see what the community is about. So assisting to meetups or speaking at meetups, I think it's a good idea to do that. So today, basically, I'm here to explain you a concept that we've been thinking about at OutZero. And what I want from you is that after the talk, if you can give me your feedback, if you think it makes sense, or if it doesn't, or what would you change, that would be awesome. So my name, as he was saying, is Martin Gontaunicas. But since we're in the tech world and everybody knows each other from the Twitter handle, my Twitter handle is mgonto. So if you want to follow me and increase my ego, I'll be happy about it. I'm a software developer from Buenos Aires, Argentina. You may notice that my accent is kind of weird. And I work at OutZero. OutZero is a SaaS that helps you with authentication. So you basically pick an SDK for AngularJS, Node.js, I don't know, PHP, iOS. You hook it to your app or API, and you get authentication working with username and password, social ones like Twitter, Facebook, or enterprise ones like Active Directory or LDAP. If you want to know more about it, you can ask me later. And there, I used to be coding basically JavaScript all day long. So this was me. I was like coding with the machine, the keyboard. But now, I work as a developer advocate. I wish I worked with Al Pacino. I love him, but I don't. And a lot of people ask me, what is a developer advocate? And I think I wanted to do that since I was 17 years old. That's me at 17 in a karaoke, so on stage. Now, instead of singing, we're really bad. I'm speaking about technology at meetups and conferences. And of course, in order to speak, you still have to learn, and you still have to code. So today, I'm here to not talk about me, but, well, kind of. So let me tell you about a day in my life. So first of all, it was 10 a.m. I woke up really not early, so really late. And I can't wake up because still I go to sleep at 4 a.m. But I bought an espresso machine, so I drink coffee, and now I'm up. And we're actually going to OSCON soon. And we wanted a way for people to learn about authentication, about security. So I thought, why not do a quiz? And for the people who actually do the quiz, why not actually give them Bitcoin for prizes? So this is what I imagined. And I was like, that's easy. Let's actually do that. I'm mostly a front-end developer. I use a lot of Angular, like he was telling. And so I said, OK, programming time, coding time. And I finished the front-end part really easy. But then I realized that I needed to do some other stuff. Like I had to send emails, which means using an API, for example, SendGrid. I also had to connect to a Coinbase API, because my idea is that people who did it successfully, I wanted to give them Bitcoins in return. I also had to check that the Bitcoins were only redeemed once. And for that, I needed a database. So I chose Mongo. And if I need all of this, what I realized is that I cannot actually do front-end for that, because I need a server, because those APIs don't support cores, or because I can't connect to Mongo from the front-end. So I said, OK, I need a server. I know JavaScript. I'm a front-end developer. So that's it. I will just write a JS server. But wait, because in order to write a JS server, I also need to know something else, because it's really hard to do it by hand. So I said, OK, I like TJ, so let's do Express. But wait, because in order to do Express, you have to install Node.js. So I said, OK, I will install Node.js. But wait, because which version of Node.js should I install? Should I use io.js? Should I use 0.10, 0.12? What should I do? So I was like, really? Do I really need to do all of these things just to code a simple quiz which gives Bitcoins for people? So imagine that I still do it. I still do the app. I finish it. And I'm like, yay, I did it. But wait. Because that's not it. Once I finish the app, I still have to do other things, like where should I deploy this? Should I use Heroku? Should I use Amazon Web Service? What should I do? And how do I deploy this? I'm a front-end developer. Should I use Docker? Everybody's talking about Docker, so probably it's good. I don't know. Or CoreOS or something like that. And also, what if I'm lucky, which I don't know if it's going to happen, I get 2,000 people working in the quiz at OSCON. How can I make it scale? And also, how can I make it secure? because I want the people to not be able to get other people's Bitcoins. And it was like, wow. There are a lot of things that you need to do in order to make this really small and really simple app. So imagine if I would have to do actually a more complex app, an even harder app. So what I want is just that backend development is exactly the same as front-end development. What I like about front-end development is that I'm coding something, I'm trying it out, I know I should write unit tests, but I just change something, press F5 or refresh, see if it works, it doesn't, change it again, press refresh. And that's something I love about front-end. And also, I don't need to configure a server, I don't need to push it anywhere. I mean, I just push it to S3, and Amazon will take care of it. I don't know anything about it. I don't have to scale, I don't have to do anything else. So basically, what if I could actually send those emails from the front end? Or what if I could actually call the Coinbase API from the front end? Or what if I could connect to a MongoDB from the front end as well? At that point, I would be, yay, now I'm happy, because I can do front-end development and not just back-end at all. And for that, what I imagined was something like this. I have a browser which is saying script Node.js in the browser, and it's saying Node.js 0.12 meets the browser. And if we check the HTML, we will see that first we have a script which says type text node, and we just return a function that receives a context and a callback. It then calls the callback with null and Node.js plus process.version plus some context parameter. Our browser doesn't have process.version. Node.js does. But still, in the browser, we see 0.12. So somehow, this is running in Node.js. And then in my regular script, I just create a proxy for this Node.js snippet that I have upstairs. I send the parameter data to the browser, and then whatever I get back, I just show it in the DOM. So this is actually what I wanted. This is what I wanted to do. And the question is, how can we do that? And for that, I think that what we should do is, let's go back to the basics. Let's go back to how everything works. And everything works with a client and a server. And our client basically has some client code, which is the JavaScript that you write, as well as some data. And that data goes back and forth between the client and the server, and that data is entered by the user. And then our server is some server code, which are the endpoints that will run for each of the REST API calls that I do. It also has some secrets, which means if I want to call a SendGrid API or connect to a MongoDB, I need a username. I also need a password. And those are secrets that the code needs to use to connect. And also, my server is running in some computer. So it also has some CPU, some RAM memory, some operative system. And that's what lets me run this code. So I started thinking about it and say, OK, this is the client, this is the server, so how can we make this happen? How can we make it work? But thinking got me a little nervous. T-shirt time, so I'll just throw a T-shirt. And now, let's continue thinking. And if we continue thinking, and we actually focus on the server, we can do something. So let's see just the server. We have, again, the server code, which uses the secrets, the CPU, RAM, and operating system. And if we think deeply about this, what we see is that the CPU, RAM, and operating system never changes. That lets me run my code, that lets me scale my code, but that just runs my code and my secrets. So what if we could just separate that and have my server code and secrets in somewhere else, and just have my server as a runner? What if my server would be just a code runner? It would just run code. And I could have then, in my front end, this server code with the secrets which needs to run. I think that would be cool, but when I thought of that, some questions arose. Some questions showed up. And some of those questions are, OK, I need to have the connection string to connect to MongoDB. And those are secrets. If I have it in the front end, that means it's visible, because all JavaScript in the front end is visible. So how can I solve that? Another question that I had is like, OK, if I have my server code in the client, then I need to send it on every server request. And if I had to do that, how can I optimize and cache this code so that it's faster for people in production? And I need to send the server on every request in this model, and that doesn't work because it's spending a lot of bytes, a lot of request time for me, which I don't want. So we'll come back to this in a moment, but first, let's actually see it in action. So this is basically what it would require to have our runner. It would be just a server with one endpoint, which has this run, and we just send whatever we want to run. So in this case, what we want is just to return a function that receives a callback and then in this case says hello world. So let's actually copy this and let's try it. So if I paste it here, you will see that I just get this hello world, because in this case I'm saying, okay, run this code, run this function, and the callback says no error and return me hello world. So it's just returning hello world. So let's try something else. Let's try, for example, to return hello world plus the process.version, since that's something that should be in the Node.js server. So I run it, and now I get hello world 0.10.30. I know I should update Node version, but well, it's this version now. And what if I wanted to send some parameters? So I want to say that who is me. So then now I can receive the context, and besides saying hello world plus process.version, I can also say, plus context.who. So now if I run this, I'm getting hello world, gonto. So the idea is that we're having a runner which just runs code, and that's all it does. So the question is, what is the server for this? And the server for the minimal version is actually pretty small. The idea is that this server just receives the code in the request, it runs that code with a vm.running sandbox, and then outputs the response. That works well for this minimal example, but if we want to make a more complex example, like we want to create a server that works for everybody, we can't do this, because we need to restrict access to hard disks, we need to restrict access to the memory, to the operative system, and to solve that, we could use, for example, Docker and CoreOS, so that we can run an isolated server code runner which just runs code. But still, in the core, it's something as simple as this, which is just 82 lines of code. So demo time, I already did it. But now we have this curl. So how would we do this from a single page app? And it's basically the same. So let's see how we would code it. So let me show you first the example. You will see that my design skills are amazing. This is Bootstrap, Shumotron, that's all I know. And this example is basically the same as we just did. It will say hello to who. Here we need to enter who is the person name. And once we click on say hello, then it will say hello to that person. So we'll just call this run endpoint. So let's actually do it. Let's come here. And if we come here to the index start, we will see that we just have this say hello, this input type text, and then this button hello. And in this case, I'll be just using vanilla jQuery, and that's it. So let's code some jQuery together. So I'll have this script tag, and then I'll do the $document ready that we all love, or not, I don't know. And then in this case, we will just get the button, and whenever the button is clicked, all we want to do is just call this endpoint, and that's all we need to do. So let's do event.preventDefault, and then we'll do a $Ajax call, in which we'll say the URL is http localhost 3001 run. And in this case, we want to say that the who will come from the text. So in this case, it will be just the value of the text, which is hello.value. And then it will be a post. The data type will be JSON. And now we actually need to send the data itself. And the data is just the function that we want to run in the server. So in this case, it's a function that receives a context and a callback. And in here, we will do callback of null and hello plus context.who, which is a parameter that I'm sending. And that's it. Now I can just add this then, and then get the response, and then just do an alert of the response. And with this, the example should be finished. So let's try it out. Let's refresh. Now let's put here Gonto. And if we click and say hello, it just says hello Gonto. And in this case, the backend, which is just an alert, is working in the front end. and I'm coding it in the front end even though it's running in my backend server. So going back to the presentation, the thing is that sometimes we also need to send some secrets. As I was saying, if we actually want to connect, for example, to a MongoDB or to a Coinbase API, we need to send some secrets. And we need to make sure that those secrets are not seen in the front end. So how can we do that? Again, let's think. And again, thinking t-shirt time. This time I have 2, actually. And I have more for people who ask questions later on. But I'm very bad at throwing. So again, we're continuing to think. And let's focus again on what we were talking before. We have a server. And this server has the server code and secrets now separated. And what we want is to make it secure so that the client can see the secrets. So we just add a lock and it works. No, I'm kidding. So how do we make it work? What we want to make sure is that whatever we're sending here, we're going to make sure of 2 things. First of them, we want to make sure that whatever we're sending from the client to the server, so the secrets that were entered here, were created by this server. We don't want the people in the front end to be able to create new secrets. That's thing number 1. Thing number 2 that we want is for them not to be able to actually see these secrets. So to solve thing number 1, we can just send a JSON Web Token. So what is a JSON Web Token? Let me show it to you in a second. Wow. So this is a JSON Web Token. The idea of a JSON Web Token, very shortly, is that it's similar to a regular token, but it actually has content inside, as you can see in the right. So what's cool about this is that then I can have my server create this JSON Web Token with a secret that it knows, and add the particular secrets that we want to call something, and then just send that back to the server every time. And that works for making sure that the frontend can't create these secrets. But how can we make sure the frontend can't read them? Well, we can just encrypt those parameters in this case. So let's actually see how that would work. So demo time. So now what we will do is we'll actually send an email. So it's send email. And again, very beautiful UI, but now it sends email instead of saying hello. So I will create a 10-minute email to send it. So the idea is to, every time that the user clicks on say hello and he enters an email, we will send an email from the server, from the client, without writing server code at all. So how do we do this? We come here to our send email, and the first thing we need to do then is create our token. So how do we create our token? We have a new endpoint, which is called create token, in which first we're sending one base token, which we know, which lets us create new tokens for the clients. This would be automated in most cases, but for this example, it's just a curl. And then we're saying that the data that we want in the token is, we want an encrypted context, which will have the username and password for SendGrid. So I can write here, I don't know, my user and my password. And then I just run this curl. And what I get back, wow, I forgot to start the other one. What I get back is a JSON Web Token. So let's see what it is. So if I paste it here, now we'll see that we have this ECTX, this encrypted context, and we can't see the content of what is inside. But trust me, what is inside here is the username and password of SendGrid, which will get then sent to the server every time we make a call. So the server knows how it was encrypted, so we can decrypt it. And also, since it's signed with a secret that the server knows, because the server created this token, then we can make sure that it's from them. So this is not my real SendGrid username and password. My real one is here. So let's copy this token that I have here. And let's just write the example. So again, we will create a script tag. And we'll just save the token first. And now I'll do something that we programmers love, at least I love, which is basically copy pasting. So I'll copy paste the previous code and work from there. And now again, we have this button. And whenever the user clicks on something, we want to send the data. But in this case, which is a little bit more complicated, what I did is I created a separate file for the task that I want to run in the backend. And in this case, all it does is it does a request to the SendGrid API, sending this SendGrid user, and see that I can get it from the context as if it were a request parameter, but in this case, it's just one of the secrets that is embedded in the token. And notice also that in this case, I can require whatever Node.js dependency that I want, because they are installed in the server, so I can require them. And all it does is once it sends the email, it will just call my callback saying, OK, everything went good or everything went bad. So what do I need to do then? The first thing that I need to do is to fetch this code from my front-end app. So what I will do is then I will do an Ajax request call to get this code first. So it will just be, the URL will be localhost 3000 / examples SPA send email / send email.js, and we'll do a get. And then once we get the code, we'll just save it into a variable that we name task. I know this has like race condition problems if I click too fast, but we'll ignore them for now. So we save the code in this case, and then once we have the code, the data to send, instead of having it in line, will be just the code that we got, basically. And the endpoint itself will be the same. We'll send this same parameter, like the who is the value. And the only difference is that now I have to send that token to the header, to the server. And for that, we'll use the authorization header, authorization. And we'll just send this token that we created. And now that's it. That's all we need to do. And we're writing this send email in the front end. It will be sent to the user. And then that we are fetching it from my HTML and sending it back to the server so the server will run it. It will run it, it will send the email, and then it will get back to me with a response. So let's try it out. This will expire eventually, but let's write here. And it says email was sent. And let's actually see something. So let's try to see what was the request. So if I click here, say hello, it says again, email was sent. And if we check the post, the thing that we will see is that first, we have in here in the header the token that I created with the SendGrid username and password. And the other thing that I can see is that the request payload is the email task that I just got. So I got it, and I'm sending it on this request. And then the response is basically the response from SendGrid, which is status code 200, message success, blah, 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 blah. And if I come here now, I actually got my email, which says hello from web task sample. It's from me, and it says test email from sample. So this is cool, but the thing is that we're still sending the code on every call we do to the server, because since I just shown you, I'm getting the code from the server. I'm getting the code, which is in the front end, getting it to a variable, and then sending it to the server as the request payload. And that's not always cool, because that means two things. First, anybody can send code to this server, because they can put whatever code, and it would just work. And the second thing that it means is that it's not performant for production, because that code is sent every time. It's not cached. It's not anything. So how can we solve this? Thinking and t-shirt. So I have two more. Let's see if I can throw it a little bit further. No, not good. I should do basketball. Well, I do one to the other side. So now, let's actually continue thinking, and let's focus on the same that we were focusing before. We have the server code, and we have the secrets. So we're sending this server code every time to the server. What if instead of sending this server code to the server, we would actually send the URL to the server with the code to fetch? So we would send the URL. The server runner will just go to that URL, get the code, and run it. And then if I want to run it again, it will go to that. It will check the URL. It will see that it already got it. It's cached. So it will just run the code that it's cached. So that URL could point to Amazon S3, to GitHub, or to whatever we want, actually. So, and the thing is that also this URL cannot be changed, because it will also be part of this JSON Web Token that we're sending in the header. So let's see it. We'll go back to our first example. which is basically the minimal, which just says hello. And now what we'll do is we'll actually send the URL of the code instead of the code itself. So how do we do this? We again have to do a curl to create this token. But now instead of setting the encrypted context with the variables, we're just setting which is the code that needs to be sent to the server. If we go to this URL, it's basically a gist that says the same as before. It's return function from the callback and says hello context.who. So what we'll do now is we'll create the token. So let's go to the console, create the token, we get it, so we can check it out in JSON with token.io. And in here now we see that the code URL is part of this token. So that means that this token that we see on the left has this code URL embedded inside. So let's try it out to send it to the server. So we copy this token, and we come here to our index, and we start from the same example as before, except that now we will not send this data because it's being fetched from the URL. And all we need to do now is just send that URL. As that URL is part of the token, then we can just send that token. So we'll do authorization, better, plus whatever it is. And that's it. That's all we need. So let's try it out. Now, let's actually open the console to show something. If I write Gonto here and I click say hello, wow, unauthorized. Let's see what happened. Invalid signature. Ha! I created the token wrongly. So let's try it again. So I'll come here and change this here. One more time. Well, it's not working for some reason. Oh, thanks. And now it's saying, hello, Gonto. Thank you. Whoever it is, you get a t-shirt. So now we can see that what we are sending here in the headers is just this token. So let's try to actually do something different. So think that I'm a malicious user, so what I want is to change this. So what I'll do is I'll come here and I'll change this URL to imevil.com, well, evil with the other V, imevil.com/hello.js. So now I have this new code, so I can copy it and paste it here. Who thinks this will work? Hands up if you think it will work. That's good, because it won't. Why won't it work? Because I'm creating this new token with a particular secret that I just wrote here, which is named secret. My server is creating this token with a secret that only this server knows. So now if I try this out again, hopefully, now it shouldn't work, so now it will work probably. Now we get this 401, which is right, because in this case, it is actually 401. Because this token wasn't created by this server, it was created manually by me. And as I created it, then I can't be able to use it, and I can't send my own code. I can only send the code for which this front end particularly was specified. So now, yay, everything is working, and I'm coding front end. Because the thing that I wanted from here is that I just want to code front end. That's all I wanted to do. I didn't want to do backend. I didn't want to learn how to deploy it, where to deploy it, and all of those things. I just wanted to do front end. So this server code and secrets that we are extracting it, we called it web task so that it's easier to name and easier to understand. And we've created a web task, a site that is called webtask.io, which is basically a web task playground. What does it mean? It is a server runner that you can use. It is basically a server runner that is using Docker and CoreOS so that you can run your code and try it out in there. And you can't access the operating system, you can't crash it. So if you want, you can go to webtask.io and try to crash it, try to get the file system, and try to see if you can break it. But the idea is that you can use this webtask.io to just try it as your own runner. So you can go to the website. I'm sorry? So you can go to the website, log in with GitHub, Twitter, or Facebook, and just start playing. Another thing, all these examples that I'm running locally, I'm not using webtask.io because internet can fail. I'm using this webtask runner, which I created, which is basically this same thing that webtask.io, but instead of using Docker, CoreOS, etc., it's just a Node.js application. So you can also check it out to see how it's working, because it's the same implementation, basically. So that's all. And before finishing, one more thing. If you guys want to try out Auth0, you can sign up. It's free. So now, thank you. Anybody has any question? Was it too clear? Not clear at all? Yep.
I have a number of questions. The first one is how you know your JavaScript code in a string, does that mean you lose the syntax highlighting? Because as a developer, I really like syntax highlighting.
You lose syntax highlighting. What do you mean you lose syntax highlighting?
Like if you have the code in a single string as opposed to having the code in a file.
So the idea is that what you would do is you wouldn't have it like in a single string. You would do what I did with the send email example, where you would have some code fetcher. You would have like send email.js or whatever the name you want. And then from your code, you would either just fetch that code and send it, or you could create, as my last example, you could create the code in JavaScript, upload it to S3 or GitHub or whatever you want, and then just point to that file whenever you want it to run. So the idea is that that code itself will live in its own JavaScript. The string is just the easiest example because it's easier to see what's going on, but the idea is that you wouldn't use it in a real life.
How can I use some complex stuff such as CoffeeScript compiler or Babel or JavaScript, and how can I be able to connect some neatly?
So basically, what you will have to do is you will have to modify this web. Oh, sorry, yeah, I forgot. So he's asking how can you use like CoffeeScript, Babel, or other stuff in this backend runner. And basically, the idea is that you have to provision that runner so that it knows how to use that. So this webtask runner just runs regular JavaScript. But for example, if you try webtask.io, you can put on top like use ECMAScript 6 or use ECMAScript 7. And what it will do behind is it will just run your code that you send to the server through Babel. It will transpile it to ECMAScript 5. It will then run ECMAScript 5 and then give it a response. So the short answer is you have to make your runner know how to transpile that code in whatever you want to a runnable code, then run the code and then respond it. Make sense?
Why?
What doesn't make sense?
Actually, I'm not getting about if it's running via nodes, so we can use some libraries such as Babel itself or any other library using
Oh.
How
Yeah.
do you connect to the library?
So what he's asking is, if you're running Node.js, why can't you use Babel in there and just run Babel in there? And the answer is,
Babel require and so on.
and the answer is you can also do Babel require. I didn't think of that, but you could also do that. Or you could also require the CoffeeScript runner and then just run the code. You can do that as well.
And even libraries with node bindings are also able to be run.
Libraries with node bindings, what do you mean?
For example, native bindings, I mean, if you're working with Linux.
So if you're running that code in a server with Linux, yes, you can, but some of them won't work because if you deploy it with Docker or CoreOS, basically it will restrict access to some of the stuff. So it depends on how you configure the runner to restrict access. So most of the things will run, but some of them won't. Any other questions? Yep.
In terms of optimization, are you like, you seem like you could memorize a lot of the functions and cache them on the, you didn't talk much about that performance out on the server and the task runner.
So he's asking about caching strategies and how it performs in that backend server. And the idea there is that you can implement it however you want. What we did in our case, it's just very simple. We're having like a Redis cache or an Amazon DynamoDB cache. So every time we get a URL, we always fetch it, we cache it, and we run it in parallel and give the response to the user. So next time that that URL gets called, it will be cached. And we also have another endpoint, which I didn't show here, which is an expired endpoint in which you can send the same JSON Web Token, and what it will do is it will check if there's a code URL in that JSON Web Token, and if there is, it will kill that cache, so it can grab a new code if you want, if you updated that code in that case. Make sense? Cool. Any other questions? Yep.
You talked about scale. How do you effectively scale on web.io?
So he's asking about scaling. How does it work with scaling without actually having to scale yourself in webtasks.io? So if you do it yourself, you basically would have to scale it only once. In webtasks.io itself, the idea is that it's actually configured to work. It's working in Amazon Web Services in multiple availability zones, and it's running Docker for each of the tenants, so for each of the people that is running this. And what it's doing is we're having the CloudWatch check, and if everybody's using a lot of it, then we spin up new machines to work. So the idea is that for the concept itself is that only once one runner for one of the applications, you would have to scale it, yes. But then once that's done, either in webtasks.io or by yourself, then that's it. You don't have to worry about scaling again because it will scale by itself. Make sense? Yep.
It seems like the whole creation that you've made there is more complicated than just client-server interaction. What's the advantage beyond just being able to have client code run in a server environment?
So he's saying that what I was showing, in his opinion, is it's like harder to do than the real server code. So what's the advantage between client and server versus this? And it basically depends. So once everything is configured, and if you have like a CLI, we've created a task called WebTaskify, which is a CLI that creates the tokens for you, that checks all your tasks and does everything. Okay. So if you have that done, the only thing that you have to do, for example, I have another example, I can give it to you later. It's a tasks folder, and inside there, I'm saving JavaScript files, and that's it. And then every time I click on save, I have a watcher, which will create a new token for each of them and save it in my code. So the idea is that if you have a CLI working for you, then for you, it's just writing the server code in there.
It's like SAS for server code. Yeah, okay.
Yeah, exactly. Anybody else? I'm kind of blind, so if somebody's in the back, I don't see it. OK,
All right,
cool.
Thank you very much.
Thank you.